Now that we have a good navigation for users, the next thing we'd like to do is show more relevant information to our users. Like so many review sites, there's a lot of information in Yelp to sift through. It'd be best to develop a way to show users information that's most relevant to them personally. For example, instead of selecting the reviews of businesses based on opinions of everyone, we'd like to have reviews that show reviews written by somebody similar to the user or similar to the way they rate businesses. So our challenge in this section is to order reviews in a search result by the reviewers most like the user searching. Then we'll update the application to use this new information. The Pearson similarity algorithm is widely used to compute how strongly two things are related or really correlated. The algorithm computes a similarity coefficient that measures the linear correlation between two variables. In this case, we're looking at X and Y variables. It's particularly good for recommendations based on user ratings because it takes into account the fact that different users will have different mean ratings. And basically what that means is, on average, some users tend to rate things higher or lower than others. For example, we all know somebody who would never give a maximum rating to anything. So for them, a 4-star rating is roughly equivalent to other people's 5-star ratings. Since Pearson correlation considers these differences, it accounts for any discrepancy in how people rate businesses. Now, taking a look at the Pearson's formula is interesting. And here we're comparing A and, let's say it's A user that rates things and B user that rates things. The A sub I and B sub I are just what we're looking at in this particular instance. These are our raw observations. What did they rate a particular business or a particular type of business? And then what we do is try to center that information a bit by first subtracting the mean. How do they rate these types of businesses in general? And then what we do is we try to scale that by dividing by the standard deviation. And this helps us balance out things that may be skewed because one person rates things differently than the other. And what's interesting here, and a very useful part of Pearson, is by taking this covariance at the top and dividing it by that standard mean at the bottom, we're going to always end up with a number that is between +1 and -1. And this is useful because it gives us one number that gives us both magnitude, how much are they correlated, and the direction, are they positive or negatively correlated. Looking here at the positive correlation, we've got a Pearson similarity of 0.69. And a positive correlation, which means as X increases in number, so does Y, or vice versa, as Y decreases, so does X. So giving us both a direction and a magnitude of correlation. And the more closely an item is to the number 1, the more in step and the two variables are. Now, on the other side of that is a negative correlation. And in this case, we have a negative 0.58. As X increases in number, we actually see Y decreasing in value. So in that case, a negative correlation, which brings us to a final of no correlation, or in this case, almost no correlation. If a Pearson correlation is 0 or very close to 0, there's very little difference between the X and Y variables. And that indicates that there is, that the two variables are independent or any correlation is not able to be measured. There are two caveats with Pearson's coefficient. The first one is outliers. So since we're using the mean, you can imagine how outlier data points might pull us away from what might be a higher correlation. In this case, if we remove the outlier, we go from a 0.4 correlation to a 0.7 correlation. So if you do notice unexpected results, looking at outliers that may pull the mean in one direction or another is something to check. The other caveat that's worth noting is that there's no implied causal direction in Pearson's correlation. While it's really not unique with any correlation information, it's a good idea that if you are presenting your data, just make a note that, that the correlation does not equal causation. By the end of this section, we'll have updated our app so the user search results are ordered so that the reviews of more similar reviewers are shown at the top for our user. You should be familiar and be able to explain what the Pearson similarity algorithm is used for and what direction and magnitude of the correlation coefficient represents. You should also be familiar with how to set basic parameters such as a cutoff value.